session we are going to discuss about the Routh-Hurwitz test. So what is the main purpose of going with Routh-Hurwitz test? Any idea?
Stability.
Very good. To find out the stability. So in control system, we will be dealing with the many parameters to find out whether the system is linear or non-linear, time variant or time invariant, and the time variance versus time invariance. So coming with that points, stability is one of the main criteria to be find out in the control system. Why? Because if the system is not stable, we cannot go for the control action. If I am switching off this fan, it have to off. If I am switching on this air conditioner, it have to immediately get off, or I cannot control the system, right? So finding out the stability in a control system, it plays a major role. So first thing, if I want to find out a system is stable, I have to go with two conditions to be satisfied. So first condition is necessary condition. So what is necessary condition in sense? Let us take a characteristic equation like s power 4 plus 2s cube plus 6s square plus 4s plus 1 equal to 0. For example, taking this characteristic equation. Necessary condition stands for all the coefficient in my characteristic equation should be positive. So here the coefficients are 1, 2, 6, 4, 1. Now tell me whether these coefficients are positive or negative.
Positive.
Positive. So all the coefficients are positive, it satisfies my first condition. But still, in Routh-Hurwitz, if the necessary condition is satisfied, the system may or may not be called as stable. Now it may or may not be stable, but to conclude the stability, I have to go for the second condition, that is sufficient condition. So what is the sufficient condition is, I have to form a Routh array. In this Routh array, all the elements in my first column should be same sign. Either it may be positive or negative, but all the first values should be in positive. So how to form this array is, I am taking S4, S cube, S square, S and S0. So S power 1 and this is S0. So from S4, what is the coefficient is 1. Neglecting the odd one because I am going with the even order. I am going with the even order 1, 6, 1. Now S cube coefficient is 2. After 2 it is 4. Since the row S3 is both are divided by 2, I am dividing it by 2 so that I can cancel it and make it as more simpler. Why I am cancelling here is, if I go with the smallest values, the cancellation and manipulation work will be easier. So I am taking the common divide by 2 and cancelling it out, making the values as 1 and 2. Now for S square, I have to find out the value. So I am going with the determinant of these array. So 1 into 6 minus 1 into 2 divided by 1. So what will be the value? 6 minus 2 equal to 4 by 1. So value will be 4. And now for this value, I have to take the first column and the third column. So 1 into 1 minus 1 into 0 divided by 1. What will be the value? 1. So I am rewriting here S power 4, S power 3, S square 1, 6, 1, 1, 2, 4, 1. Afterwards, I can find out for S also. So 4 2s are 8 minus 1, that will be 7, 7 by 4. So now check for the S0 also. 7 minus 4, 7 into 4, 7 by 4 minus 0 divided by 7 by 4, that will be 1. So let me check. The first column values are 1, 1, 4, 7 by 4, 1. All the values in my first column are positive. So all are in the same sign. Whether it satisfies my second condition? Yes, it satisfies my second condition. So the given characteristic equation of this control system is said to be stable. Okay. So first condition, we have to look for the necessary and sufficient. What is necessary condition, Harish?
In the characteristic equation, all the coefficients should be in positive.
Positive. Very good. What is sufficient condition, Madhumita?
When the table, we arrange the truth table, First line should be positive
First
or
column
negative.
should be
Pos-
either positive or negative. That all the elements should have the same sign. So if both the conditions are satisfied, then we can conclude the given system is stability. Okay? Thank you.